Today we're going to be discussing section 1-3 from our textbook, which is measuring angles. Okay, so I'm just going to jump right in. The vertex of an angle is the common endpoint of the rays that form the angle. Okay, and we know that a ray is just an endpoint and an arrow going in undefined infinite direction. Okay, but it is terminal at the endpoint, meaning it ends at the endpoint. And usually we want another point that the ray goes through so that we could name this ray. And in fact, I'll take this as an example, this ray from this angle right here. I'm going to say that Z is this endpoint right here. Y is the point that we go through, and that ray goes infinitely through that point Y and onward in that direction. So if we take a look at our example right here, we have a vertex, okay, which is the common endpoint to both rays ZY and ray ZX. Okay? We got a siren coming on. So let's take a look at this. An angle may be named by its vertex. So we can name this angle right here as angle Z, because the vertex is that common endpoint of these two rays. We can name this angle also by naming by a number, in this case the number 1, okay? And that's only really important when we have multiple angles coming off of that vertex. You would see a diagram with something like maybe angle 1, 2, and 3. And then just to differentiate between these different angles, you would name the angle by the number, okay? We can also name an angle, okay, by the vertex and the point on each of the rays that form the angle. But we want to make sure that we label or we name this angle in this method by putting the vertex letter in the middle, sandwiched in the middle. So in this case, they can name this angle as angle YZX, which we've done right here. We could also go the other direction and name it angle XZY. Okay. So if you need a minute to digest that, I would just suggest pausing the video, but I'm going to go on. Okay. It says you cannot name this angle by ZYX. Why is that? Well, because the vertex angle is not sandwiched in the middle. We always want to go from one ray to the vertex to the other ray. And in the same token, we cannot name it as XYZ because that would be going from this point over to this point and down here, which is technically that angle up there. So always make sure when you're naming an angle by 3 points, okay, 1 point on each ray and that vertex, make sure that vertex point is in the middle of the naming scheme. Okay. Angles are measured in degrees. I'm sure many of you have seen that in your earlier math classes. For instance, if you see 30 degrees, the degree symbol is this right here. It's just a measurement for the amount of how much an angle opens up. So for instance, if I create a ray right here and I create another ray right here, the degree measure is just essentially how far these two rays are separated from each other in a rotational manner. Okay. All right. So the measure of an acute angle is between, I'm going to go ahead and write it, 0 degrees and 90 degrees. And now I'll explain why. If an angle is 0 degrees, then that means we have some ray right here, and there's another ray superimposed on it, and there's actually no space. This ray hasn't even opened up from the other ray. There's no degrees, so we wouldn't want to be a 0 degree angle. Okay, so an acute angle is an angle between 0 degrees and 90 degrees. 90 degree angle would look like this. Okay, I show it on the diagram with this symbol right here. And that means if we have a 90 degree angle, we call that a right angle. So the measure of a right angle is 90 degrees. Okay. The measure of an obtuse angle is between 90 degrees. We can't be 90 degrees. Why not? Well, because then that would be a right angle. Okay. And 180 degrees. Okay. So anything from this point right here onward up to a full 180 degrees is going to be an obtuse angle. So that would be something like this. I would call that an obtuse angle. I would even say that's an obtuse angle. Okay. I wouldn't want to say this is an obtuse angle because that's the right angle. I wouldn't want to say this is an obtuse angle because that's an acute angle. Okay? And I wouldn't want to say this is an obtuse angle because that's technically a 180-degree angle or a straight angle. And that's the final angle name we have. So we have 4 different categories of angles depending on their measure. We have acute angles, which are between 0 degrees and 90 degrees. We have right angles, which are exactly 90 degrees. We have obtuse angles, which are between 90 degrees and 180 degrees. And we have straight angles, which are 180 degrees exactly. All right, if you need a minute to take a look at that, you can go ahead and pause your video. I'm going to erase this and move forward. So let's go ahead and take a look at example. This is the example. I'd like you to draw this diagram on your paper and pause for a minute as you answer these questions to the best of your ability. And when you're finished, I will continue as we walk through all of these. All right, so what are 3 other names for angle S? In this diagram, it appears I can name this as angle 3. It appears I can also use the 3-point naming scheme. Going from here, that direction, I would say it's angle RST, where the vertex is clearly this S point, and that is sandwiched in the middle of these other 2 points. And I could also name this going the opposite direction, angle TSR. Again, making sure the vertex is the center, is the middle point in those 3 points when we name it in that method. Okay. What type of angle is angle S? Well, angle S on the diagram clearly shows a right angle, so we would say right angle, which is 90 degrees. Okay. Name the vertex of each angle. Now, these questions don't apply to the diagram. Okay, these are their own. We would just want to draw a general sketch of an angle. I don't know if it's acute, right, obtuse, straight, but I'm just going to draw it as I see it. L, G, since G is the middle point, that's going to be the vertex. H, and sure enough, like I just said, that would mean G is the vertex. So in the same way, I can look at this one without even drawing a diagram, and I would know that point B is the vertex for that angle. I'll just go ahead and write point G here. All right, so if you need a minute to digest those answers and compare them to your own, go ahead and do that now by pausing the video. But I'm going to erase this and go forward. The angle addition postulate. The angle addition postulate allows you to use known angle measures to find an unknown angle measure. Okay? If point B is in the interior of angle AXC, so I look at this diagram, I clearly have the angle AXC. And it says if point B is in the interior, that just means somewhere kind of in the middle right here. Okay? I don't know if maybe it's here or here or here. I'm just going to draw it towards the center just to make my diagram easier. Okay? If that's the case, then the sum of angle measure AXB, okay, and the measure of angle BXC is equal to AXC. Well, what does that mean? Well, first what I want to do is with that point B, I want to draw another ray through that. So now this problem will start to take form, okay? It says if this is the case right here, if B is the interior of this larger angle right here, then the sum of the measure of angle AXB, which is this angle right here, the sum of that, sum being addition, and the measure of angle BXC, which is this right here, okay, should be equal to the measure of AXC, which is this total angle of the 2 smaller angles combined. And I think you can see how that would be the case, okay, just using your intuition. So I want you to copy this down in your notebook and make sure you understand that this is the process, using these as the general points for your angles, naming your angles. This is called the angle addition postulate. Okay. I'm going to move forward, and we're going to try an example of the angle addition postulate in action. All right. So the problem says if the measure of angle LYN is equal to 125, what are the measures of angle LYM and measure MYN? So this takes a few steps. It looks like we have angle measures for some of these angles given as algebraic expressions. So let's take a look at this. If we know that the measure of LYN is 125, what is angle LYN? That is the total angle, so keep that in account, okay? And we know that's 125, all right? I'm going to go ahead and rewrite my angle addition postulate for this diagram using these point names specifically, all right? And I'm just going to write that at angle addition postulate now. It's the measure of angle, let's just take this one of the smaller ones, LYN, plus the measure of angle, the other smaller one, MYN. That should be equal to the measure of angle. Well, what's the name of the total angle? LYN. You could have also named any three of those angles the opposite direction, and for the total angle, you could have named it NYL. The only reason I named it LYN is that matches what I see in the problem. Okay, so now let's go ahead and plug in our unknowns and see where we get. All right, so the measure of LYN. The measure of LYN, it appears I've made a mistake. Rather than make this whole video over again, what am I going to correct? And it's okay to make mistakes. I'm going to correct this right here. That should be what? That should be LYM. Okay? So the measure of angle LYM is given as what? 4p plus 7 degrees. But for the sake of this problem, I'm not going to include that. The measure of angle MYN is given as 2p minus 2. And the measure of angle LYN is given in the original word problem to be an amount of 125 degrees. All right, so if we look at this, now let's go ahead and combine like terms and solve. So we get 6p plus 5 equals 125. Minus 5 here and here, we get 6p equals 120. Divide both sides by 6, we get p equals 20. Okay? But we don't want to know p. We want to go one step further and find the measure of angle LYM and MYN. So the measure of angle LYM is given as 4p plus 7, where p is now 20. So the measure of angle LYM equals 87 degrees. And I always want you to make sure you have your units. If it's an angle measure, make sure you have your degree symbol over here. And I also want you to tell me in your answer what you're looking for. So don't just include a number. That's just a floating number. I don't know what that applies to. Make sure your answer includes that you're saying that the measure of angle LYM is the 87 degrees. And in the same fashion, we're going to go ahead and say the measure of angle MYN is equal to, I'm going to write the algebraic expression, leaving a space for p. So it's 2 times p, where p is now 20, right here, minus 2. And of course, all of that is degrees, and we'll show that in a second. So let's go ahead and say 2 times 20 is 40, minus 2 is 38. So I have 38 degrees. That is the measure of angle MYN. Okay? And you know that these two together are the smaller angles, and the total angle should equal 125. So what you can do is you can take these two measures, add them up, and make sure you get 125. All right, guys, that completes the video notes for section 1-3. Have a great day.